In this lesson, the goal is to explain why certain values for the distance and time in the red car's journey results in the red car going the same speed as the blue car. First, Kate and Christopher examined the table they made in the last lesson. They had recorded what happened when they tried to make the red car go the same speed as the blue car, which traveled 10 miles in 4 minutes. Kate and Christopher's table has several columns. The first column records the distance traveled in miles by both the Lamborghini and the Ferrari. For example, the 10 means that the blue car, the Lamborghini, travels a distance of 10 miles. The 5 means that the red car, the Ferrari, travels a distance of 5 miles. The table also shows the amount of time traveled in minutes by both the Lamborghini and the Ferrari. For example, the 4 under the L means that the blue car, the Lamborghini, travels for a time of 4 minutes. The 2 means that the red car, the Ferrari, travels for a time of 2 minutes. The table also shows which car travels faster or slower than the other car. The equal sign means that the 2 cars traveled at the same speed. The table shows which car arrives at its destination first and which car arrives at its destination last. Using the table, we can see what happens in each race. For example, in this race, the Lamborghini travels a distance of 10 miles in a time of 4 minutes. The Ferrari travels a distance of 20 miles in a time of 8 minutes. The 2 cars travel at the same speed. The Lamborghini arrives first, meaning that it stops first. The Ferrari arrives last, meaning that it stops after the Lamborghini. In this episode, Kate and Christopher make sense of the patterns they notice in this table. They look at the number of miles and the number of minutes for each car.
The last time we were together, you found lots of same speed values for both distance and time to make the 2 cars go the same speed. In this lesson, your goal is to explain why the same speed values work. But first, let's remember what patterns you discovered. So I have your work from last time. Do you remember this?
Yes, I remember that.
Yeah. So Kate, I'm going to have you start. I want you to take a moment to look over the table. And Kate, what is one pattern that you notice about the values that made the 2 cars go the same speed?
The 10 always have 4 minutes all the way down to.
So the Lamborghini stayed at 10 and 4, and the goal is to find this to make the Ferrari go the same speed.
Yeah.
So what is one pattern you see that made the Ferrari go the same speed as the Lamborghini?
Yeah. The one with the amount of. I can't think.
Do you want to try one of them?
Yeah.
Which one do you want to try?
The first one. Actually, the second one.
Which second one? The 10 and 20 and the 4 and 8?
Yeah.
Okay. So can you show me 20 and 8? 20 and 8.
20 quid and 80 quid.
Okay, so before I say go, will those go at the same speed?
Yes.
Why?
Yes, they will.
Why?
Because 10 times 2 equals 20. 8 times 2 equals...
So
4 times 80.
what's the pattern then?
Times 2.
What'd you say, Kate?
Doubling.
What do you think about the word doubling?
Doubling. Also, it could work like this. And
16.
16? So hold on a second. Will that be the same speed?
Yeah.
Why do you think they're going to go the same speed?
Because the Ferrari has 40 miles to go and has 16 minutes to do it. The Lamborghini has 10 miles to go and 4 minutes to do it.
What do you think, Kate?
Yeah, they just doubled.
No,
just
not
doubled?
doubled.
Oh, well, it's triple. It was
Quadrupled.
Whatever it's
Quadrupled?
Yeah.
Okay. So
Let's test.
let's see what happens.
Say,
Can you put
Told
the pen
you.
down for? Where do you see the same speed?
stop, reset, go, and tap. Okay.
You could just double it forever and
Ding, ding,
ever.
ding,
And always
Okay.
just
Kate and Christopher noticed a pattern. Kate called it doubling. Christopher explained that the values for the red car's distance and time are both 2 times the values of the blue car's distance and time. Then they used the doubling pattern again. By multiplying each value by 2, they found that if the red car travels 40 miles in 16 minutes, it goes the same speed as the blue car. Christopher said that the distance and time values for the blue car had been quadrupled. That means that the values for the red car's distance and time are both 4 times the values of the blue car's distance and time. Next, Kate and Christopher notice another pattern.
We just keep track of our same speed values. So you have 10 and 4.
who live here.
What's another pair?
There was 20 and you can make a chart just doubling.
So yeah, okay.
Yeah. 30, 12.
How's that doubling?
That didn't
Oh,
double at all.
sorry.
That's triple.
Well, is that
Wait,
another
whoa,
pattern?
whoa, whoa. Yes, that is another pattern. You'd have to draw a line through this. Actually, if you put all 3 of these down at the same time, they'd all go at the same speed. Don't undo it.
Yeah, hold on to this. Because you have one pattern called doubling.
Yeah, you could just also
Yeah, I
look
actually
and I heard
added 4.
what'd you say?
I actually went by 4.
Yeah,
Is that
would
a
still
problem?
work.
Yeah.
No,
Because
it's not a problem.
it's not going by.
It's not a problem at all. Here. So this would work. So
Why do you
would this and this and this.
What do you think, Kate?
and This.
Yeah. Was that it?
All of them would work. I could continue going
Right.
forever.
What are you doing? What's the pattern?
There's 6.
What's the pattern, Christopher?
Okay,
So the pattern is adding 10 for these and adding 4 for these.
Kate and Christopher discovered an interesting pattern. Christopher said that if you keep on adding 10 miles and 4 minutes to the blue car's journey, you can get a list of distance and time values that all result in the red car traveling at the same speed as the blue car. He also said that this pattern could go on forever.